In this example, we're going to divide here and then see whether or not the quotient ends up being a monomial. And if it is, let's find its degree. All right, so it looks like in the numerator we have a monomial here. We have a number and it's being multiplied by a couple of variables with exponents. So we can go ahead and simplify this by doing 6 squared, and that's 36. So we'll have 36 and then of course x cubed, y cubed. So let's look at the bottom here, this denominator. It looks like we have 2 cubed, which is 8. And I can go ahead and multiply that 8 by the 3 and get 24. And it looks like the x and the y to the 5th will just kind of come along for the ride. Okay, so let's slide over a little. And it looks like this 36 and 24, I can actually divide a 12 out. So when I do that, in the numerator it looks like I'll have 3. In the denominator it looks like I'll have 2. So let's now look at our variables. We have x cubed in the numerator and x in the denominator. So remember, when we're dividing like bases, we can subtract their exponents. And the exponent here is a 1. So 3 minus 1 is 2. So in that numerator, along with the 3, I'll have x squared. And that denominator was 2. Let's go ahead and look at these y's for a second. So we have y cubed and y to the 5th. Well, it looks like we have a larger exponent in the denominator. So when I subtract, it's going to be 5 minus 3, and it will be left then in the denominator. So it looks like the quotient will be 3x squared over 2y squared. But is this a monomial? Well, it's not, because even though we have 3 halves, and that's being multiplied by x squared, this y squared in the denominator kind of indicates that we're dividing by this y squared. So this is not going to be a monomial. So there's no reason to find its degree. So not a monomial for that quotient, and there's that example.